Hi, everyone. Welcome to another episode of the Student Spotlight series, where we showcase some of the work our past students have done. Today, it is our pleasure to have with us Emir Tataroglu. So, Emir, can you tell us a bit about yourself, where you're from, what year of school you're in, and what course you've taken with CCIR?
Yeah, hi. So I'm Amir. I'm a junior. I live in Florida, and I took the one-on-one mentorship course.
So, who was your mentor and what was your project focused on?
So my mentor was Dr. Mushtakov in astrophysics. My project was focused on high-energy astrophysics mostly, and it was called Electron-Positron pair production in magnetospheres of X-ray pulsars.
Okay, cool. So, how did you become interested in the program?
I found it out online.
And but having found it online, why was it something that was interesting to you?
Well, I've taken a lot of courses in physics, but I can never find somewhere to learn how to apply them into actual tangible research. And so I thought that CCIR was perfect.
So how did you choose your topic, or how did you sort of develop your project with your mentor?
Well, once I signed up for the program and I in my essays, I wrote about what I wanted to do. What they do is when a professor picks you, he kind of proposes a topic to you, and you can kind of object or accept and propose the differences you want to be made. So Dr. Mushtakov came at me with the idea, and I really loved it because I always wanted to do something relating to modern physics of compact objects, which are neutron stars and black holes.
Mm-hmm. So how is the program structured for you? How did you sort of begin to do your research, and then how did you sort of transition into writing?
So in the first half of the program, what we did was the first half of our meetings were comprised of kind of educational lectures, and the second half we started working on the project. And then once the lectures were over and the project had kind of progressed a decent bit, we started writing.
So once you finished the project, what do you feel like were your sort of key insights or takeaways from the process?
Well, firstly, I learned a lot about high energy astrophysics, but more importantly, not only was it my first experience doing a proper research paper under the guidance of a professor, I also learned how to do research. And I feel like this program kind of trained me in now being able to do independent research effectively without needing a mentor. So I feel like it set me up for future projects really well.
That's great. So you definitely intend to continue doing research, I suppose, in college.
Yes, for sure. Yeah.
So regarding the project itself, like what were your conclusions? How did you sort of contribute to or extend the literature that you read?
Yeah. So the topic we discussed, or we discovered, I guess, it wasn't. It was pretty new because the idea, this phenomenon called pair production, though it had been studied in high magnetic fields, it wasn't applied to neutron stars previously. So what we did was we kind of applied them to a specific type of neutron star called an X-ray pulsar, and we made predictions and theoretical discoveries, which essentially we haven't observed yet because we don't have the technology, but they kind of give a basis for future observation. So they're completely new, and such observations or such predictions hadn't been made yet.
Yeah, that sounds exciting,
For sure.
Yeah. Do you think you could explain, like, maybe in layman's terms, what that phenomenon you referred to as? You say was hyperduction?
Pair production. So when you have a really strong magnetic field and you have a photon, which is a unit of light, given the right angle and the right energy, it can split into an electron and a positron. Or a positron is the antimatter version of an electron. And essentially, when photons are emitted from the surface of these neutron stars, they can split. And so my work was kind of on that. I simulated, and it was kind of analytical work as well.
So,
And it focused on these things called X-ray pulsars, which are a specific type of neutron star that's in an accretic system, binary, which is just you have two stars, and the neutron star kind of pulls in the mass of the larger star near it, and a sort of like a vortex, I guess you could call it. And the reason we're interested in those is because they have a strong enough magnetic field for pair production to occur, but it's not overwhelming enough for every single photon to just not be able to escape.
So you kind of touched on this a little bit, but I wanted to ask more about your methodology. So you mentioned that you did simulations. Can you say a little bit more about, I guess, your method? How did you collect your data, and how did you analyze it?
So data was primarily just from other literature that I found, and especially my professor sent me, but also in our simulations, you would just use equations and models from previous literature, and you would apply them to simulations, and that would give you your data. So essentially, when you simulate, you're creating data, not using it. And then with that data, you would analyze it and maybe create a new model or draw conclusions.
So do you feel like there are any practical ramifications to the research that you did, or any sort of clear next steps if you wanted to continue this project?
Yeah. So one thing is, right now, we don't have any great models for this process in neutron stars. And so what we used were the best approximations we had. Whereas if one wanted to spend more time on this topic, you could go deeper and deeper into kind of the physics of it and try to almost create a new mathematical model. And I feel that would take a lot of time and effort from a lot of different scientists, but it's definitely there. But there's also a really exciting road in 5 to 10 years. Though we're not sure about this, there will be satellites launched that will be able to detect the energy band that I worked on, which are called gamma ray photons. And so within the next decade, observations will be made of these X-ray pulsars and the gamma ray photons that are emitted from them. And so my work could be confirmed or not confirmed by observational evidence.
Do you think you could say more broadly where your interest in physics comes from? Sort of how did you become so passionate about the subject?
I don't know. Since I was young, I was just really into it. I got into it through like YouTube videos, the ones that you would find everywhere. And ever since middle school, I've just been learning as much as I could. And I feel like CCIR gave me a platform to apply that knowledge to real world situations.
Do you feel like, so yeah, speaking of, I guess, applying your knowledge or sort of going from just sort of being a student to doing active research, was there anything about doing research that you found especially difficult or surprising, or was there kind of a learning curve?
There was definitely a learning curve, I think. Just in general, learning how to write a paper. It kind of takes a while to learn and to kind of dip your foot in. But I feel like also kind of scanning through literature and finding the right paper that you want to apply. That also takes a while, because you can just find a lot of papers that are outdated or have been withdrawn, or just don't have what you want. And so kind of just scouring literature takes a while as well. In the end, it's a completely different skill than just knowing physics.
Yeah, definitely. Can you say a bit about how your mentor sort of supported you in that writing process?
Yeah, so he was really helpful in the sense that not only did he guide me throughout the entire paper, gave me tips and gave me feedback, he also kind of taught me how to do stuff. And we use this software called Overly, which is where you can kind of collaborate on a PDF of a paper in LaTeX. And so for me, that was also a learning process for that, because I hadn't used it previously. and he helped me with that as well. I feel that even though it was my paper, my professor contributed a lot, um, and it's almost like a guiding light.
So have you finished the paper? Are you planning to publish it or take it to any conferences?
Yes, I'll be taking to multiple conferences this spring, as well as we're currently working on publishing it in the Journal of High Energy Astrophysics.
Great. Yeah. How's the publishing process been going?
Good. So we kind of wrote the paper with no journal in mind initially, but different journals have a lot of different um, kind of formatting they want, and so it takes a lot of time to format them. And some journals, for instance, they just want to see results and not your methodology or your models. And so it's a lot of different editing for different journals and to see kind of which one's best for you as well. Whereas conferences are a little easier, you just submit your paper. Yeah.
Yeah, I definitely think that, I mean, I guess I imagine you haven't published a paper before, right?
No.
So yeah, it can be I think I guess at least in my experience, I feel like the publishing process can be a little bit overwhelming. But do you feel like, so you mentioned that I suppose maybe this is ground that you've already covered, but you mentioned that coming in, you weren't really familiar with how to conduct research or write a research paper or presumably publish one. But
Yeah.
now you feel confident that this is something that you could continue to do independently in the future.
Yeah, certainly. I also think that given it's almost been like an eye opener because going to the program, I had no idea what to expect. So I was pleasantly surprised at a lot of turns. And I was also kind of disappointed in one thing, not with the program, but with the process in general, where in these peer-reviewed journals, the referees have weeks and weeks to review your paper. And so you submit it, and if it's accepted, a random professor is assigned that's not connected to your research, and they're given a month to give you feedback. And when you respond back with your edits, they have another month to give you feedback. And so because of this, it takes 3-4 months to publish something. And yeah, that's really unfortunate.
Yeah, I mean, it can take even longer, depending on how much of a back and forth there is. I have a friend who only just got an article published maybe this month that he wrote, I think over a year ago. So yeah, and definitely there's a lot of people take issue, like not all the feedback you get from the referees is good feedback. So depending on, so it's yeah, it can be a frustrating process, but you got to do it. So do you feel like if you were to, if you could give yourself some advice, if you were to do it again, or if you could give someone else doing a similar program any advice, what would it be?
I guess to just be as creative as possible. I think that initially I was just trying to get everything done, but I feel that kind of seeing where the research takes you can be really rewarding because obviously your professor gives you, that your next step should be this and this, and of course you should do that. But I feel that as opposed to like a homework problem or reading a textbook, you have a lot more freedom to just kind of, especially if you're doing mathematical research like me, because physics is inherently mathematical. You just get to kind of play around with the models you're given and see if you can find anything that's relevant, or there are different just points of view to a problem. And sometimes that's happened to me. I worked for like hours on something, and I showed my professor, and he's like, "Oh, that's nice, but it's not going to be relevant to what we're trying to do." And in such a case, you can either scrap it or leave for later, but you can also add it to an appendix for future kind of reference. So I feel that one of the things is it's just really creative, and learning to really have fun with that is something I wish I'd done more.
Yeah, I think that's good advice. I think that definitely, when you're just sort of when you're a student and you're sort of just in a sort of purely pedagogical environment, usually you're given sort of problems that the professor already or the teacher already has some idea of how you should solve in advance. There's a particular way of doing things, and it's just a test of if you can do things in that particular way. But when you do your own research, there's no sort of set way to solve the problem in front of you. You could solve it in any number of ways, and you don't really know in advance how things are going to go. And yeah, I think that definitely it's great advice to try to embrace that creativity or have fun with that.
Yeah. If you just look at it as I want to reach my goal of finishing the paper, then it can be kind of frustrating at times just because kind of it's unpredictable. On the other hand, if you want to enjoy the ride and kind of do your best work, then I think it's a great experience.
Yeah, definitely. Do you have any other final thoughts that you want to share about your experience?
No, but I do think that it was an exceptional experience that I really loved, and I would recommend it to everyone.
Yeah, well, I'm so glad that it was so positive. It really seems like, it really seems like it was productive for you. So I'm glad. Well, in any case, thank you so much for your time, and thank you for sharing about your project. I really enjoyed talking about it.
Yeah, thanks.